This video is about reviewing how to reduce radicals. So we want to simplify and answers must be exact. That means we cannot type this into our calculator and get a decimal. We're looking for reduced radicals. So in number one, we have the square root of 16 over the square root of 84. We know that those are both perfect squares. So the square root of 16 is 4. The square root of 64 is 8. Both of those are divisible by 4, so this reduces to 1/2. In number two, we have -5 times the square root of 9. We know the square root of 9 is 3, so we have -5 times 3. Because it's perfect square, our root goes away, and when we multiply then, we get -15. Now, in number three, we're not so lucky. We don't know the square root of 40, and if we try to type in our calculator, that's going to give us a decimal. So we need to use a factor tree in order to reduce the radical. So we want to find numbers that multiply to 40. So there's a bunch of different factors we can use. One set of factors, though, is 4 and 10. 4 can break down to 2 and 2. And 10 can break down to 2 and 5. How do I know when I'm done with my factor tree? Well, you're left with prime numbers, which means if I was to make a branch from them, I'd be using that number and 1. So I know that I'm at a prime factor then. So now I want to look and see, do I have any pairs of a number? So I have a pair of 2's. So I'm going to cross one out and I'm going to put one outside the radical. Now the other 2 and the 5 do not have a pair, so they are stuck underneath the radical together. So they are going to multiply. 2 times 5, so we get 2 root 10. In number 4, we have -3 times square root of 120. We don't know the square root of 120, so we know two numbers that multiply to 120 are 12 and 10. Two numbers that multiply to 12 are 4 and 3. Two numbers that multiply to 4 are 2 and 2. Two numbers that multiply to 10 are 2 and 5. So again, I'm going to look for pairs. So I have a pair of 2's. I'm going to cross one out. Now, we had this number out front. So we need to keep that out front with any pairs we have. So we're going to do -3 times our pair of 2's. For numbers left over, we want any number that does not have a branch coming from it. It is not circled. So we have 3, 2, and 5. So we're going to multiply those together under the square root. So we get -6 root 30. In number 5, we have -3 times the square root of 16x squared. So we know that the square root of 16 is 4, so we have 3 times 4. Now, the square root of x squared, remember that the square root and square cancel each other out, so we are left with just x. So when we multiply, we would get -12x. In number 6, the square root of 20x to the third. Now, we don't know the square root of 20, so we're going to make a factor tree. So we would have 4 and 5. 4 would break down to 2 and 2. So we would have a pair of 2's, and we would have a 5 left under the radical. Now, for x cubed, if I was to write this out, it would be x times x squared, which would be x times x. So I have a pair of x's. That brings the x out front like in number 5, but we have this other x left over, so that's going to stay under the radical. In number 7, multiplying square roots. So when you are multiplying a square root, remember that your outside numbers are going to multiply together, and your inside numbers are going to multiply together. So 7 times -5 is -35. 8 times 2 is 16. Then we see if we can simplify our square root. So the square root of 16 can be simplified to 4. So we have -35 times 4. And we can multiply that together then. So we get -140. In number 8, when we multiply, -9 times -3 is 27. 15 times 20 is 300. 300 is not a perfect square, so we're going to simplify. So this can simplify to 30 and 10. Now to save us some time, 30 simplifies to 3 and 10. Now, usually we want prime factors, but if you see a pair already, you can use that pair. So we see that 10 is our pair, so we're going to bring 110 out front with the 27. and we have that 3 left under the radical, so this would be 270 root 3. In number 9, we have a square root outside of a parenthesis. So we are going to distribute and use our same multiplying rules. Because 7 doesn't have a coefficient in front of it, that's a 1. So when we multiply root 7 times 2 root 6, we get 2 root 42. And when we do root 7 times negative 5 root 3, we get negative 5 root 21. Now, if I try to simplify this, 42 breaks down to 7 and 6, 6 breaks to 2 and 3. There's no pairs, so that's as simplified as we get. Same thing with 21. 3 and 7 gives me no pairs, so I'm simplified as far as I can go. In number 10, when we multiply and we distribute, we have 8 root 6 times 3 root 12. So 8 times 3 is going to be 24, and 6 times 12 is going to get us the square root of 72. And then we have 8 root 6 times 6 root 10. So that's going to get us plus 48 root 60. Now we need to see if these can simplify. So 72 can break down to 36 and 2. 36 can break down to 6 and 6. So we have a pair of 6. So we're going to do 24 times 6 root 2 left over. So that's going to get us 144 root 2. Then with 60, we have 6 and 10. 6 breaks to 3 and 2. 10 breaks to 2 and 5. So we have a pair of 2's. That's going to multiply with the 48. And then we have a 3 and a 5 left under the radical. So that's going to get us plus 96 root 15. Because they have different roots, they do not combine together. In number 11, we have 9 root 45 plus 12 root 20. So right now they do not add together. We need to simplify to see if we can combine them. So when I simplify the square root of 45, I get 9 and 5. 9 simplifies to 3 and 3. So we have a pair of 3's to multiply with the 9, that's a coefficient, and a 5 left over. So that gets us 27 root 5. For the 20, that breaks to 4 and 5. 4 gives us a pair of 2's. So we have plus 12 times 2 root 5, which gets us 24 root 5. Notice that they have the same roots, so they're allowed to combine together. So we're going to add our coefficients of 27 and 24. So we get 51 root 5. The number under the root does not change when we are combining them together. In number 12, we have negative 19 root 54 minus 6 root 28 plus 10 root 24. So 56 is going to break, 54 is going to break down to 9 and 6. 9 is going to break to 3 and 3. 6 is going to break to 3 and 2. So we have a pair of 3's to multiply with the negative 19. We have a 3 and a 2 left over. So that gets us negative 57 root 6. 28 breaks to 4 and 7. 4 breaks to 2 and 2. So we have negative 6 times 2 root 7, which gets us negative 12 root 7. And 24 breaks to 4 and 6, which is 2 and 2. So we have 10 times 2 root 6. So that's going to get us 20 root 6. So the root 6's are going to combine together. So we have negative 37 root 6 minus 12 root 7. It doesn't really matter which one you write first. Now, when we are reducing fractions that have a radical in the bottom, we can never leave a radical in the denominator of our fraction. So first thing we want to do is we want to see, does it simplify at all? So we notice that 12 is divisible by 3. So that's going to leave us with root 4. 50 and 10 also divide to get us 5 root 4. We know the square root of 4, so we have 5 times 2, which gets us 10. In number 14, we have 2 over root 11. Now, this does not completely simplify. We can't reduce anything. So we're going to multiply by the radical on the top and bottom. So we're going to multiply by root 11. So on the top, that's going to become 2 root 11. On the bottom, root 11 times root 11, the roots are going to cancel out, which leaves us with just the number 11, and nothing else reduces. In number 15, we can multiply by root 3 on the top and bottom, so that gets us 6 root 3 over 3. These numbers on the outside can reduce with each other, so 6 divided by 3 is 2, so we're left with 2 root 3. In number 16, the root on the bottom is root 5, so we're going to multiply by root 5 over root 5. So we get the square root of 35 over 5, and we can't reduce anymore. In number 17, we can multiply by root 2 over root 2. So we get 17 root 10 over 10 times 2, which gives us 17 root 10 over 20. Again, we cannot reduce that. In 18, notice that these do reduce with each other again. So that gets us root 2, and 20 is divisible by 4, so that gets us 5.